All right, we'll try this. I may have to go back. We're actually live, so they're going to have to see this.
Rest, but the only one post that you need, like, just get rid of everything else and just post, because post is
All right, well, I guess we had some technical difficulties, so we're just going to go with Plan B. So we'll be starting in a few minutes.
Have them in a post request, and then it's like,
All right.
Live?
We're live.
All right. All right. The pizza was very good. Well, my last house, we had a brick oven pizza, so we kind of did a lot of experimenting with pizza. You know, the crust is important, and the sauce is really important. So I had the cheese pizza because if you can have a good cheese pizza, you know, it's kind of a good way to tell whether or not the pizza is decent, because you can do anything once you build on top of a cheese pizza. But the crust was good, the sauce was good, and the cheese was good too. Anyways, so yes, I'm Jason Haley, easy to remember, Jason. I'm originally from Indiana, but I live in the Boston area now. I am a .NET developer, started with .NET back when it was in beta 2. I was doing VB before that and trying to learn Java, but could never find work doing Java, so I never ended up going much down that other than some classes that I took. You know, I had to do Java. And I'm still predominantly C# developer. I'm an independent consultant, and I've started getting into AI stuff late last year. So I'm kind of learning this. As I learn it, I like to speak it and write about it and try to get hands-on with it to make it stick in my head here. That QR code is for my LinkedIn if anyone wants to connect. This slide deck is going to be available. It's already out there. I've got a QR code at the end and a bit.ly that you can get the slide deck. It's a PDF I made available. So anyways, before I get started here, I'm not going to go into presenter view because I want to go in and out of PowerPoint. And also give you an idea what's coming up. Sometimes, you know, when I'm sitting back there, I'd like to see kind of a preview where the speaker's going. But before I get started here, how many people consider themselves an application developer here? Okay. Architects? How about what else do you have here besides application developers? Students? No students?
I'm a recent college graduate.
Okay, that's pretty close.
Yeah.
How about the data scientists or ML people? On the fence back there? Okay. All right. What programming languages do you guys predominantly use? C#?
C#? Yep.
C#? Python?
Yep.
Python, okay. Wow. All right, well. I can read Python, but to write a greenfield project in Python, I would need Copilot help. So anyways, my demos and stuff are purely in C#. So you guys are predominantly application developers, which is good because I want to give you links and the ability to toy with the demos that I'll be showing, because it's all available out there in GitHub. And I'm not going to be showing any of my code. I'm going to be showing other code that I've found useful as I'm learning this. Is there anyone here with the questions that they really wanted to get answers to this evening? And I can see if I can gear some more material towards it. If you guys have any questions or you're like, I want to know specifically a thing or two. No? So you guys are just here to learn about RAG. So how many people know what RAG is, or Retrieval Augmented Generation? So we've got a half dozen people out of about 18 people, 20 people. So that's not bad. How many people have written a RAG application? Yeah, okay. But you toyed around. You know the concept, you can do it, right? So anyways, that's what I'm here for this evening, is to really gear this presentation towards you all who kind of know what it is or don't know what it is, but you're here to learn. And I'll show you how to get started with it, more or less. It's not an advanced presentation about the different things to do or how to do it, though I will get into a bit of that. So, all right, good. We got the right audience here. So ChatGPT. Everyone knows what that is, right? Does anyone here not know what ChatGPT is? My mother. I tried to explain it to her earlier. I'll show it. So ChatGPT, it came out in November 2022. And since then, it just became really popular between late November and January 2023. It got up to 100 million users. Anyone have an idea why? Or you can kind of see some of my notes down here, but what do you all think? What really made it catch on? Anyone?
Accessible.
Successful?
It's like in the sense of like it's human. It's a much more human way of interacting with data and answers and things like that versus knowing how to Google or knowing the right things to say.
I totally agree with that. I mean, I've done some ML code camps and stuff before, and to me, it just feed a bunch of images that look like show parrots, and then some that don't show parrots to train a model. To me, that just didn't sit with me. But chatting with something, a language model on the back that was using AI, started to get me interested in AI. But it wasn't until about July of last year that I'm like, you know what, I got to pay attention to this. I'm not one of those leading edge guys, because I've worked a lot with financial companies throughout my career, and they're hardly ever on the latest version. They're hardly ever doing betas. They want to make sure it's tried and true. They get their ROI out of what they're purchasing. I mean, it's got to provide business value. So I kind of waited, but once I got into it and started learning more about it, it became more and more interesting. So one of the things that, besides it being really accessible and it, just providing good value, it was free. That also, I think, played a bit to it. And it may have had something to do with it being kind of around Christmas break time. That to me would also be kind of fun. And it being late 22, not everyone was out doing all kinds of stuff quite yet. So the other question I have on here that's kind of important, do you think anything in the technology world's really changed since ChatGPT came out? No. Nobody's gonna bite that one on?
There definitely have been things that changed from a school perspective, because I was actually at college in 2022 when it launched, and I was actually doing a senior thesis on related to that space, where I was working with sentiment analysis. So it was like I completely had to change my senior thesis from going where I was going because of it.
Okay, so that's kind of where I wanted to go with this. Everything that ChatGPT builds upon has been around for a long time. A lot of it's been around since like the 50s, and the large language models, that really is relatively recent, but it's like someone opened up a window of what you can actually do with this stuff outside of the group that already knew the machine learning and the AI, the people that were already in the know. So I'm a Microsoft AI MVP now, where before I was an Azure MVP. This year I was renewed as an AI MVP. And I was asking a lot of the AI MVPs that have been MVPs for a long time in the AI space. I asked them, like, so does it feel like, people who had tattoos back in the day when it was the bad thing to do, how do they feel now that everybody's got a tattoo? Is that the way AI is? It's like AI is popular now. It's not, it's not that nerdy thing that means you really know your stuff. It's like now that AI is popular, is that a turnoff to you guys? That kind of thought it was funny. And one guy made a joke about RAG being actually the tramp stamp of AI, because RAG has been kind of, well, you'll see. It's very easy to get a RAG application up and going, and 80% of it works great. But that other 20%, you're going to spend a ton of time getting it to work. And to throw it into production, you got a lot more stuff to do. But it's a great place to start. And really about this whole space is you need to understand what the tools are, what they can do before you can really start thinking of new ways to utilize it. So anyways, we'll get to ChatGPT in just a second, but these are kind of the phases that I see for LLM usage. And it's great that you guys are all application developers, because this is what I want to focus on, using an LLM as a tool for an application. So there are kind of 4 phases. One is just the general awareness and usage of it. What can you use it for? What does it do for you? And then the second phase is kind of where we're going to spend most of this talk, is where you bring external data that the LLM wasn't trained on to it to reason over it and give you some value back. So that's where we're going to be spending a lot of the time. But agents is the next big thing, and that's where it's kind of a multi-step process, but you're still using the LLM to do reasoning on the back. So a good example that I would think of for an agent for a meetup is, we had pizza this evening. So why couldn't you have an agent? It knows from the meetup all the data on the meetup site. It knows where the location is. It knows how many people have RSVP'd. It knows what time it starts. So you could come up with an agent that, so say, well, you maybe need like a 20% vegan option. And so you would need to set some parameters, but it could order the pizza, out of the area that could deliver it to the location that it knows about on the specific time. So an agent is that workflow, that multi-step workflow, not just the, summarize this email for me and give me back the highlight bullet points that people typically use in LLM. So an agent's that next step of usability, of really creating these big things. And the last one is the tools. I mean, for these LLMs to stick around and really become one of those tools where we have non-deterministic systems systems being built about features that are really non-deterministic. If that's really going to catch on and go across enterprises, it's got to be providing business value and tools. So that is kind of like the Ubers for a mobile phone. Whenever Steve Jobs introduced the iPhone, I was actually working for a company that built the OS for AT&T's mobile phones, and it was very, very controlled. So whenever Apple announced the iPhone, it was pretty clear the writing was on the wall. They were stealing the control from the carriers at that point and moving it to the actual cell phone providers, or the OS cell phone providers. But nonetheless, the thing is, with the cell phones, it was all apps, but they weren't being built like an Uber app. All of that stuff is built just assuming that underlying technology functionality. All right, so enough of this. Let's take a look at what ChatGPT is, so we can continue on here. So this demo has changed a little bit. So this is the 4th time I've given this talk, and it's always a little different each time I give it. But like, this is where I go to ChatGPT and I say, okay, just to demonstrate what it will do is what's caused the American Civil War? So just a historic question. If we would go to Google, it would come back with a set of, a page of links and a little description of what's on those links. But ChatGPT comes back with an answer to the question I asked. Those are different models. This one's not providing any ad revenue for any other people because it's just giving me the answer. That's why I paid them $20 a month. Although this is probably it's available for free, but I'm not sure if I'm actually logged into my account here. I do pay the $20 a month. So it came back with a nice summary of what it sees as the answer to the question that I asked. And it's a language model, so I could ask it something like, here, I've got a nice question here. So the idea with this is I'm going to ask the same question, but like thinking of this language model as, say, an intern. Like, okay, a little more information here. I think my paste pulls over some stuff from OneNote or PowerPoint. But anyways, I'm giving it some instructions. I said, tell me why the Civil War started, give me at least 3 paragraphs, and give me some bullet points. So it's like talking to an intern. You just don't say, something general and expect them to give you back exactly what you want. You have to give them some instruction. And look at this, it came back with what I asked for, 3 paragraphs and some bullet points. So that's a language model. That's artificial intelligence. It's trained on a lot of text. And since it's been trained on so much text, it actually has knowledge, because that's kind of how we communicate knowledge, is through text or language. So that is an example of ChatGPT being used for asking questions. And it would sum something up as well. If I give it an email and say, could you give me the highlights of this email or sum this email, it would do so. I mean, that's a language model, so what it's trained to do. But now if I ask it something like this, what's the weather like in Boston today? Anyone have an idea what it's going to give me?
Hallucinate.
What's that?
Hallucinate.
It'll say it doesn't know current events, it'll give you its time out.
Well, it used to do both of those things. Now it actually has a RAG step. It's going out and searching for, actually it looks like it may be getting the wrong date, but it actually goes out. ChatGPT will do searches now. So if I ask it for who won the Super Bowl this year. Now, for those of you who have used ChatGPT for quite some time, will know that there's a couple of tricks with this one. One is, I'm saying this year. It's a language model. It has no idea what today is, because it was trained up to a certain point, and it's no longer being trained. It's inferring what you're asking. It's just like a tool maker who makes the machine that then does the work. So the machine's just doing the work. It just knows how to answer questions. It has no idea what this year is. So it should come back with, you see, it's searching for Super Bowl 2004 or 2024 winner. So it came back with the answer now. That's RAG. It went and got external data somewhere else and then came up with this answer. So it now does RAG where it didn't used to before. So if I go to, are all you guys Azure users? Yeah, or a lot of you are anyways? Okay, cool. So Portal, which is good. I used to be a Azure MVP, so that's good. We like to see Azure users. So let me show you basically as if I'm interacting with the API. So if I go to Azure and I create an Azure OpenAI resource, and then I go to the studio. All right, so I'm just going to go to the playground. I guess it's called chat now, not playground. And then we dismiss this stuff. Can you guys see that screen? I should bump it up a little bit. We're just going to use the defaults. And now if I say, who won the Super Bowl this year? So this is API access. So this is going to be what you guys were thinking it was going to be. Saying, I don't know. I was updated as of October 2023. Don't know. If I say, what is the weather like in Boston? It may come back with what typical weather is in Boston, or I may just say, no, I don't. So that's the expected result of ChatGPT until I was preparing for this presentation today. I gave this same presentation in early May, and this is what ChatGPT used to do. But they've since added functionality that will do the RAG step for you, which makes their application so much more useful, right? I mean, who wants to see this? Like, why I pay you $20 a year? Can't you do that? Or $20 a month? Can't you do that query for me? So they do that query now. But if you are building an application and you are calling the API, you get that dumb response. embeddings. It's up to you to do that additional step. So that's ChatGPT. It will answer questions for you as it can, and sometimes it will say it doesn't know, but oftentimes it'll just give you an answer. So my general advice, when you start thinking about building applications using LLM as part of that stack, is it's not good practice to use as a data source. So, I asked it a historic question, and it gave me most likely an accurate answer. But if I'm to ask it, so if I'm, the typical demo is an HR department. If you're an HR department, you don't want the LLM to know the answers to your latest policy updates. You want to provide that. So that's the better practice, is you more or less have two systems in a RAG application. One is the retrieval step, where you're getting the context and giving that to the LLM to answer the question. So think about it. If you're in HR, if you're building an application for the HR department, you have all these policies that you really need to build the application. So the end user of the company can ask questions about their insurance plans, what the coverages are, whether or not scuba diving lessons are covered, or, what's the vision plan? Can I get glasses and contacts, or is it one or the other? Questions like that from policies that are there, it's just no one reads, or websites that are there that no one reads. So you gather up that content, and you need an accurate way to search that to give them the relevant pieces along with the question that the user asked to the LLM to then come up with a question. Like the Civil War question, the LLM was trained on tons of data. Some of it had to do with American history. And probably a lot of it had to do with American history because it was trained on so much data. Think of it the same thing with RAG. You need to give it enough context so that it can answer that user's question. Scuba diving lessons covered. Well, then your application, your retrieval application, needs to be able to retrieve the relevant parts and send some of that to the LLM along with the user's question to come up with an answer. So that's kind of what this RAG application does. It provides quality context for the LLM to do its job that it wouldn't know otherwise. So it's a lot like, again, an intern. You have an intern in your company, you want to kind of give them some information about how things work at your company before you start asking them to do things that are specific to the company or to answer questions specific about the company. Kind of the same thing with a RAG application. So with this retrieval application, it's a pre-step before you're talking to the LLM. The goal is you want to provide quality knowledge to the LLM to do its reasoning part. Again, kind of think of an intern. So this is kind of a flow of a RAG application. You've got the user asking a question, and then you have this retrieval part of the application. Uses data sources. It doesn't have to be a database. It doesn't have to be a vector database. It could be an API. It could be any other source. It could be just some rules engine that you have that spits out some stuff. But the results of this retrieval system are going to be a portion of what goes to the LLM along with the user's question. So you'll have a system prompt that does usually some safety stuff and some setup as to the persona that you want the answer to sound like. The user prompt is usually the user's question, and then this context is going to be the context coming out of your retrieval system. Then the LLM takes all of that and then comes back with what seems like magic when you start playing with these things. But when you start building the application and you hit that one edge case, then it's like, oh, it's not magic. There is work involved in making this thing do what I want it to do. All right, so before I get into another demo, any questions yet? Any questions? Okay, so before I get to the demo, does anyone know what embeddings are? So we have the back row. Who knows? They're nodding. The Python people, they know. So embeddings are good. are going to be important. They're not necessary, but they're the way most RAG applications do this semantic search. So like I mentioned, the retrieval part, you've got a system that's trying to retrieve the relevant information. These LLMs have a context window, so you can only send it so much data. Some of them are very large, so you can send them a lot of data, but you get billed on that amount of, you get billed on what you send to it and what you get out of it. So you got to keep that in mind. You don't want to send all your HR policies just because you can fit them in that context window every time a user asks a simple question. You want to build this retrieval system that can get the relevant pieces out of those policies and only send those in that context window to answer the question. So that's where embeddings come into play. And we'll talk a little bit more about them in the next slide. But with this demo, so this is a Blazor server application written in C# by a gentleman named Michael Washington out in LA. I met him this year, a pretty smart guy. He's working on an AI application himself. He's a writer, so he's working on an application that you kind of describe the plot that you want, and then it actually writes fiction for you. He's tackling the frustrations of trying to get it to nudge in certain directions. But anyways, this is his application. The code's out on his site. I have got links at the end so that you can get it yourself. I will give you a warning though, don't upgrade the packages unless he's done so, because a lot of stuff's changed since the version that he wrote them in. Just build it and compile it and play with it and understand it, and then you can build your own. So let's see if this works. I don't recall if this comes back with an answer. Okay, all right, double click, sorry. All right, so it doesn't know. How can I bring my own data to Azure OpenAI? And I've tweaked some things on this so that it wouldn't do that. What I've fed this system is this PDF. It's any runners in here? Ever run any half marathons?
Yep.
Ultra marathons?
Not ultras. Not that great.
So this is an ultra marathon in Arizona. I think it's 240 miles. I'm a runner, but I've never run anything this long. The longest I've ran is 50 miles. This is 34 pages long. So what I've done is I've copied the text from each of these, and I've put it into the application, and it's gone out to OpenAI and gotten embeddings for each of those pages, and then stored it in a SQL Server database. Everyone familiar with SQL Server here? Cool, awesome. You guys are my crew here. So SQL Server, so the reason that I start off with this demo is because this is the one that really made it click for me, because he uses the technologies I'm familiar with. He uses SQL Server to put his embeddings in it. Out of everything I've seen written, I've never seen a Python application that's a RAG demo store anything in SQL Server, let alone the embeddings. That's something that you would never, ever see a Python demo do. So he wrote this demo, Blazor. I've done Blazor applications. He uses SQL Server on the back end. I've used SQL Server for so many years. And this is what really made it click for me. He's just accessing LLM via API. I've used tons of APIs. This is not that different than any other application that we write as a C# developers. So you can see this is just your typical file about ultra marathon. You know, they got to kind of cover their bases. You know, where are the restrooms? When are withdrawal, cancellation, gear requirements? How many hours do you have to cut off? That sort of thing. So that's what I've fed into this system so that we can ask questions to it. So, I mean, very important. You run 240 miles. Are there restrooms? I spelled that wrong. I'm a little ambitious on the O's there. Yes, there will be portable toilets at every aid station. All right, cool. So it found it. So, you know, I could go to this and I could say restrooms, and I do a search. So it found it on page 18. There's the word restroom. So what if I just say restroom? All right, so it, of course, there, because it's the same thing, S. Okay, so restrooms also in the index. It's also on page 6, restroom use on course. So that's it. That's where restroom is. So that's a keyword search. It's looking for that restroom in the text. Everyone's written a search application, right? Or you at least know how to query SQL Server and say, hey, you know, where's restroom in this text? So that's great. What if someone doesn't use the word restroom? What if they say porta potty? What if they say washroom or facilities? Well, that's not going to come back. If I say washroom, there's no washroom in here. But if I ask the app that uses ChatGPT, or I should say OpenAI API, are there washrooms? Oops. One thing I don't like about this is that it's not the enter key. I have to do tab enter. I don't know how many times I do that. It just gives me the same answer as restrooms. So it knows enough that washrooms and restrooms kind of mean the same thing. That's where embeddings, that's embeddings right there. It knows that in a meaning, those are the similar pieces of information. And when you ask for an embedding, what happens is you come back with this. For the embedding that it's using is it comes back with 36. I think it's 1536 floating point integers. And that signifies what that means. So if you compare washroom and restroom by a different, the ADA recommends the cosine similarity to compare those. If you utilize that, they come back with very similar scores. So they question.
Is it distance based?
Yeah, distance space is what it is. So everyone said, not everyone, there are different ones, but with ADA, what happens when you pick an embedding, because there are multiple embeddings. I'm using the ADA 2 here with OpenAI, and OpenAI actually has some others as well, but there are a bunch out there. Yeah, question.
So for querying the embeddings in SQL, are you having it be like a table with 30,000 columns, and then you're doing a cosine similarity metric to kind of pick a closest? Like what are you doing?
Okay, so you want to know about implementation details. All right, here we go. So it actually, SQL Server will do I believe it's a column span index. So if I show you what's in here, here's the tables. So it's kind of what you would think. I've got an article, so I've got the document. Let me show you the counts here. Oops.
So is it vector data?
Yeah, it's not. So what you're getting at, SQL Server does not currently support vectors. It will do an index across floats, and that's what this is doing. So for 32 pages, we have 401 chunks and 615, almost 616,000 floating point numbers to recommend that. So it's one row per, so it's 1,536 rows in this table for one chunk. So that's not scalable. We all know that's not scalable, right? That's where vector databases come in. Vector databases, that's what they do, is store this sort of information a lot more efficiently than what I'm doing on this. And SQL Server, Azure SQL Server currently has a private preview. So if you're interested in doing this with SQL Server, they have a private preview for vector storage. Cosmos will also do vector storage, and so will Azure Server. But this uses SQL Server. This is not efficient. This is not efficient. It is not going to scale. This is one 32-page document, and we've got I mean, it's ridiculous. It's 616,000 rows, but the app works great. And again, this is kind of what I'm saying is a RAG application. You can get it looking really good. You can get it what it feels like 80% of the functionality there, but you can't move this to production. This will fall apart in production. I mean, it just doesn't work. But yeah, so this is what's in the database. But if I go back to like the search, so here's the searches, and I've got a full. I got to change the database here. I've got a full text index. Anyone ever done full text indexes on SQL Server? So that'll do some fuzzy searching, but still, it's not going to help with washroom. When you get restroom, you get basically the result that we saw when we were doing the search in the PDF. What did I do on the very bottom one here? Okay, so the bottom one is more of a, this is the full text search where I'm going to do a restroom or restrooms, but it also won't come back with any washroom because it has no idea that that's the same thing. That's, so yeah, I don't have the index here, but that is indexed for, the cosine similarity is actually done in a stored procedure. Okay, so it actually does the math. And I don't know if it's technically the full, it could be a dot product versus a cosine similarity. But there are multiple algorithms for comparing these long vectors of numbers. But there are also different embeddings, as I was mentioned. So images, you can give an image to an embedding model, and it'll give you back a series of numbers to represent what that image means. You can also do, there's audio, but they're not compatible. So there's also with OpenAI, they have at least 3 embedding models that come to mind that do text, and they're not compatible. If you take your chunk, so I showed all the chunks in this one. Was it 400 and something? Yeah, so 401 chunks. So a chunk is a term that you'll hear a lot. What that means is they took something larger and cut it into pieces. Because think about it. If you only have, say, this is not apples for apples here, but say you have 1,000 words to describe a 32-page document. You can only use 1,000 words to describe that 32-page document. But if you cut that document up into 401 pieces, and you get 1,000 words for each of those 401 pieces, you can do a better search because the descriptive level is smaller. So it can be a lot more description in a smaller chunk than a bigger chunk. Does that make sense to everyone? So I call it kind of fuzzy and clear. You know, I just went to the eye doctor. And so, you know, you turn in the thing, it's fuzzier if you've got too big of a chunk. So your embeddings aren't going to grasp a level of granularity as if you lower the chunk size. But you do need to play with it. It does differ. And not all embedding models are thousands of floats. Some of them are small and number-wise. So so this application is great for getting those concepts that we just went over down because it uses SQL Server. The similarity logic is in a stored procedure. It's all here. It'll show you how to do it. Only thing you have to do is either use OpenAI. You have to get an API key so that it will actually talk to it. You have to spin up SQL Server and populate it with whatever data you want. If you go to this data tab, this is where I populated it. So you can just say load data, dump in a title that you want for it, and then the contents. So this demo is totally approachable for anyone who's got SQL Server, .NET background. All right, so jump off of that. So that I think is really, really good starting place for learning this stuff. All right, so kind of back to our searches here. So we showed keyword search, the restroom stuff, and then we showed semantic search where I can use washroom and still get the same response as restroom. So the keyword semantic makes sense, and the hybrid probably makes sense too for you, where it's basically you do the both, but there's also this sense of re-ranking. It can get complicated if you try to do your own re-ranking. But think about it. If you say, give me keyword search and I want to take the top 50 results of that, and do a semantic search and I want to take the top 50, but I want to re-rank those off of the original question I was asked. That's where additional logic comes into play, or the tool that you use, because there are re-rankers out there that you can use as API based, like Cohere has one. But Azure AI Search also does re-ranking. It'll do a hybrid search as well as re-ranking for you, and that is useful. For instance, if you're writing a system and you see how powerful semantic search is, you may wonder, why would I need keyword search? Well, if there's an employee database and I'm looking for something related to JSON, there's a lot of JSONs. I mean, we got 2 in the room here. Any other JSONs? We got at least 2, and we all seem to be about the same age. It was a popular name, apparently. And I would want JSON to be an exact match, not a semantic search match. I would want it to look for Jason Haley. So I would find the relevant stuff in the retrieval system related to Jason Haley. If I'm searching for a price of, I'm looking for boots that are less than $19.95, I want it to search for $19.95, not the semantic meaning of $19.95. That's where keyword still plays a role. It's not something you can throw away because we have this fancy embeddings model now that allows to do searching by meanings. Meanings is not everything. That's where, again, you can get that RAG system looking like it's great, and then someone throws something like that at it. It's like, I just threw a price $19.95 at it, and it has no idea what I'm talking about. It just starts coming back with gibberish because the system, it was built around meanings and not exact matches, or the ability to filter off of a number greater than or less than. That's not going to help you with semantics. So you need to keep that into account when it comes to searching. So embeddings and vector databases, there are the 3 embeddings and the sizes that they typically take. It gets more advanced. You don't have, with the 3s, you can get away to not use the complete dimensions because some of them are empty. So that's a lot more advanced, a lot more than what I'll go into. The vector database, I mentioned 3 of them, or 2 of them there that are Microsoft, the Azure AI Search and Cosmos DB, and I mentioned there's a private preview for Azure SQL. Pinecone, Chroma, Qdrint, those are all, well, they're not all open source. Pinecone is not, I believe Chroma is. Qdrint, I don't know if Qdrint is open source. But anyways, they're vector databases. They're geared toward dealing with these large numbers. And think about this. So I showed you the massive numbers, or the massive count that I had for that small document. Think about if you have an HR system with thousands of documents and you wanted to find the cosine similarity of all of those numbers, all those embeddings, all those chunks that would result from those thousands of documents. It's trying to compare an array that's this big against all the others in the database. I mean, you're going to come up with that issue of what's in that case. How many are we comparing this against? Because it's going to go through that whole index to do a comparison, and it's got to run an algorithm on every one. It's not like an index in SQL Server. 1 is the first row or second row, depending on how you count. It's not going to say, okay, 1 is right there. It's got to do a similarity search across all of those. That's what vector databases do. They store that stuff in a way that makes it more efficient to do that sort of math, specifically to do that sort of math. So that's why you hear a lot of people mention vector databases. It's solely geared towards embeddings in those large arrays of numbers. Okay, so we mentioned chunking quite a few times already, but some of their challenges. It can be challenging. So you're basically taking a document and you want to chop it up into pieces, and then the idea of those pieces are that they're kind of grouped in meaningful ways. So if you have a document and it's already paragraphs, then you kind of think that paragraphs would make sense to be a meaning. Okay, so this paragraph means this, this paragraph means this. I used pages for my demo that I just showed, but you got to keep in mind the meanings there. If we go back to this document here, some challenges just on this page. So we have, and again, if you take this into account that this is a PDF, getting text out of it isn't always that easy. We have one line of text, and then you have a table. So that one line of text is related to the table, and then the table really isn't, it's not how you would read text. It's not, you start from one side and you go, and you go. You kind of look like aid stations. Okay, well, here's the aid station, aid station. These all have the same meaning. These are all aid stations. But if I took, say, this as a chunk, then, that'd be a list of aid stations. Give me a list of aid stations, and it would be able to come back with some meaning there. And then these are the miles of those aid stations. So it's like tables are harder than just text. So you had to take that into mind. And if you had an image, so there's so this is cool. And it, like GPT 4.0 is starting to really shine the light on how some of this can improve. Like, you can give it a document that has text and an image, and it can recognize that text. If you try to take this out of the PDF without some tool that will do character recognition, then you're going to lose that meaning of what all of these pieces of text are in there. And I honestly don't know how anyone would really be able to decipher this as an elevation chart and what the elevation is for the individual points. That's a challenge that you'll have whenever you're trying to chop these documents up into chunks and be able to provide a system that can provide a search that would be able to decipher that. It's just a challenge. I don't really have a solution for you there. But these are things that you have to take into account. And whenever you're doing some documents and some text, you may really consider an overlap of like 10 to 20%. What that means is it'll carry some of the meaning from the previous chunk over to a chunk. That way it helps it be related. Like say for instance, this page is a chunk, but I'm not quite sure how to do this, but maybe this would be better. So say you want the headings to carry over to the or you want to make sure the headings together, but say you're doing paragraphs, then this paragraph would want to bring in this heading. So if this was a chunk, because we're doing paragraph chunks, this would be a chunk because it's a paragraph. This would be a chunk because it's a paragraph, but you would want that to be carried over so that this goes along with this meaning. And in that case, it's a heading, so it would make sense. But you might want some carryover from the previous chunk so that the meaning carries over with it. It's just a strategy that you see out there with a lot of the chunkers, is they'll allow you to do an overlap, and typically it's 10 to 20% of the size. But typical chunks for text documents are paragraphs, sometimes pages. That's kind of a big one. Typically it's smaller than that. And they're almost always token-based, not word-based or character-based, which is tokens, 70% of word typically. Yeah, so I mentioned the tables and images. Images get tricky. But one strategy I've seen to get past the image is people are using like a GPT-4 to come back. So they use a crafted prompt to have it describe what's in the image. and then they store that stuff in the embedding. So that's one way to get around some of that stuff these days, which that's kind of new. That's just come out in May. I mean, there are other APIs available besides OpenAI. Just want to put that out there. I am purely talking about OpenAI, but there are many others out there. So data sources, these are just some that I've seen, and I'll mention a few things about it. So documents, typically they're chopped up into individual pieces for the chunks, and then you have to pre-process those. So that's part of your retrieval system. You have to get the data for your retrieval to come back with the relevant stuff that your LLM can utilize to answer the user's question. So that's all pre-processing, or indexing, some people call it. And yeah, so database, you kind of, the next demo I have is it's a database on the back end. It's a Cosmos DB. It's not SQL Server DB. It's Cosmos DB. But they've decided out of, say, a product object, which fields really represent the meaning for that row. So if you have a product description, a product name, ID, created date, maybe some other stuff that really doesn't add meaning, like an ID or a created date or last updated by the person, last updated date, you wouldn't want those to be used in creating an embedding to represent what that row means. So that's something that you have to take into account when you're using structured data. And something I don't mention here is like a graph database. Well, graph is another way to get a lot of additional metadata from another system before you connect it to the RAG system. External API, that just totally makes sense, and there's I could do a whole another talk on just function calling to do APIs in your own system. But that's your typical data sources for, say, a RAG application. So let's look at this other demo. Actually, I've got to go to here. Any questions yet? Is it starting to make any sense, or is it still just? Okay. So let's see, demo 3. Demo 2 didn't work. Didn't deploy today, which is okay. I'll still show you the code base so that you can download it. Maybe you'll have better luck with it. Oh. Okay. So this is a relatively new demo that was released, I think it was late last month by the Cosmos DB team. One thing I'm not impressed with is the performance. I've looked at the code. The code is pretty, I won't use the word impressive. It's interesting. It's really good reference. But whenever you see the reality of how slow some of what they're doing is, I can't say it's anything better than a great reference application, because what they do, and I haven't found another demo yet that does, is they use Cosmos DB for the vector store. I haven't seen another demo that does that, and it is written in C#. The first version of this demo used Azure AI Search. It used the data, the structured data was in Cosmos, but they used Search for the vector store. So let me ask it. So this has products and customers. Not a lot in the database, but it proves the point, and I'll show you some of the code to show you what I was referring to about, the embeddings and all that stuff on the object. So I say, actually, I've got some questions here to save my typing. So it's customers. So I see a few of you are a bit younger than I am, but some of you about my age. Has anyone ever been asked to build a system that would mean you wouldn't need to write a report, that a salesperson could kind of do the report themselves? Anyone ever been asked to do that? No? You're lucky. I've had a lot of product people think that you could write a simple system that would allow a sales guy to not need to ask an IT guy to create a report for it or a data extract. You know, they would just be able to query a system and say, can you can you give me the customer's, you know, first name, last name, email? Because they don't know how to query a database. You know, it's like, I need a report to do that. I've shut people down that, you know, doesn't make sense. So they would see this and they say, hey, this is great, but it's like, oh, can you type, can you format the phone number like, let's see, as number and make it an HTML thing. Who knows if this will work? Let's see. Oh, yes, it actually did. So it did create an HTML table. This application is not actually built to do this sort of thing. It just kind of works. So it comes back and says, oh, yeah, sure, I can do that. But it does do all this extra spacing where if you were building this for someone, you would need to take that challenge on. But it is actually an HTML table. It formatted, I didn't ask for bold, but it did a good job at that. And it formatted the phone number how I wanted it to format. Just simple text asking it. And if you notice, there's another challenge in here that you'll run into. So I asked it earlier to give me that list. I didn't ask it for that list again. I assumed that it knows what list I'm talking about. So that also is another challenge. That's history there. And that's also going back and forth in the context, because asking these LLM APIs are stateless. That's got to also go to it. Say, okay, so here's the previous. So actually here, this app will show you the prompt. Yeah, so view the prompt. So here's the prompt, or some of it. It's not all here. It gives you the system stuff. You're an intelligent assistant. I like to hear that. You are intelligent, so apparently machine does too. So it has the history somewhere in here. So there's the first name, last name, the history right there. The history of the current conversation is user. That's the question I asked. And then the answer is assistant, answer. So it provides that in the history when I asked the second question. So that's something you have to keep in mind too, because that's extra money I didn't ask it to spend, but I needed it to do that in order for it to do what I asked it to do. So that's just another thing with these systems that you have to take into account. But so this system is this right here. Build your own Copilot. With Azure Cosmos DB. So one of the guys on the Cosmos team, Mark Brown brought it to my attention. It used to have there's another GitHub repo that was the first version of this. They moved it all to this one. So, but it's C# application, uses, anyone familiar with Azure Developer CLI? So we have a few heads nod. Okay. So what it basically is, so here you choose which infrastructure you want, because this will actually spin it up in AKS as well. I spun it up in containers, Azure Container Apps. So you choose which one you want. Once you clone the repo, you can choose which one you want. And then you say AZD up. Yeah, right here. So this is all I ran. So I cloned the repo. I changed to Infra Acta because I wanted it to be container apps and not. And I said AZD up. And then I waited like at least 15 minutes. And then it spun up all the resources for me. That's what Azure Developer CLI will do for you. Is they give you the ability to create sample code, great sample code. It's great for sample code. You can use it for your own code base if you want. But it allows you to have that code base, everything. You do have to write the bicep, of course, for it to create those resources. But all of that's in this repo. And you can get it spun up really easy by just saying AZD up. And you can tear it down by saying AZD down. And then purge will remove, like, I'm not sure, OpenAI resources in Azure used to not do a hard delete, they do a soft delete. So you'd have to go in and then delete them. I'm not sure if they fixed that, but container registries, because it uses containers on the back, will leave the registry around as sort of a soft delete. So there are some resources that do soft delete, but the purge will make it do a hard delete. So that it doesn't have to wait the whatever days before it clears it. So that's kind of important. But this is a great demo to learn how they do things like they do a lot of caching. They do a semantic cache, which I've never seen anyone do. I've seen people talk about it, but they actually do a semantic cache. So if I'd asked the same question twice, it doesn't actually make the call the second time. It just returns a cache, which is useful, but I'm not sure if there's like a knob on that. You can say, I want it to be this close to semantically similar, or I want it to be exactly similar. I don't know. But let's see, how are we doing on time? I gotta get going. So anyways, I've got these links. You can check them out and play around with it in your own time. It's a C# application. That was actually supposed to be this demo. This one is the one I couldn't get running. It's a demo that does PDFs, so it's an unstructured data, but it's also out on GitHub. I'll show you. But to kind of roll up or round out what we've seen in demos and discussed so far, the chat completion request is how it's making that call to the LLM. So all the other stuff was focusing on that retrieval part, that system of retrieving stuff and how to get out what you need. But this is geared solely on that call to the LLM. Some things to keep in mind. So whenever you're using the API, there's multiple types of messages. One of them is a system message. That's where you kind of set the persona and some of the rules up to the LLM. And then the user is typically where the user query is. Sometimes the chat history is shoved in there. The assistant is the response coming back. And then the tool it's a whole nother topic in itself. That's a function call that API will make. Yeah.
In the previous example, you used Cosmos DB. I was curious to understand what did you store in that data?
It is just rows of products, rows of customers, and then embeddings. And it actually stores the history too. So the history of all of the application. So your session of your chat, that also gets stored in there.
How do you link them together? Meaning, okay, this customer, assuming this is not going to be static data, right? So customer data changes all the time. So when you're placing a request to API, what exactly are you sending?
You are sending, you're first doing the retrieval step before.
Right, okay.
So you're just sending the context of that retrieval step and embedding search and the history and the user's request.
Okay. So you're just making a query and then embedding that into a prompt and then sending it off.
Yeah, it's not that fancy.
Okay.
There are a lot of things that it could do. I mean, one thing that I am kind of impressed that it does do, like for instance, I've asked it about customers at this point, right? And it listed 3 customers, and there are actually more customers in there. I don't know. So what's going on here? But now if I ask it, how many customers are there? Do you guys think that it'll actually come back with, say there are 3 customers?
Mm-hmm.
Yeah, you think, well, how many people think it will say, yes, there are 3 customers, or they'll say there are 3 customers? Or how many people think that it really doesn't know how to answer a question like that? I mean, that's a summation total.
I think it would do 3.
That's it. Are you gonna come back?
So for that to work, you have to send this entire customer list every single time. Right? How else would you count it?
Let's see if it
I don't
comes.
know. Let's see.
See, this is why I'm not super impressed with this application. I mean, let me ask it again. How many customers are there?
And
But
I'm
all-
also
all counts.
considering the token count usage. Look at that, it's starting to pile up.
Yeah,
Before you know that you're using a lot of tokens,
yeah. So
the cost will add up.
it came back. There are 3 customers. So it answered the question, and it answered the question because it's in that history. Otherwise, it can't. Doesn't
If
have.
you went to create a new chat and did it in context and asked that same
Yeah,
question,
it would say I don't know.
Okay.
So if I say create, well, if it knows, that means it still has it in the cache. Because when I do it straight out of the gate, it doesn't know. Yeah, so it has to have that history for it to say, oh, there are 3 customers. Yeah. With this one, so some of the other points is it does give you a token count on this one, which is useful. Not all demos do that. They don't show you really how many tokens that conversation is. So the token coming back was only 18, but I sent 653 with that simple little question. So anyways, there are other things that you can, little knobs you can turn whenever you make an API request. At max tokens, you can say, hey, don't go over this number of tokens. Response format, if you do want it to come back as JSON, you have to specifically ask it, and you have to, well, you can usually get it to come back if you give it an example and say return it in JSON. You don't have to always say the response type is JSON format, but it is something that OpenAI does provide. Streaming is what gives what if you look at what's coming back, is it's coming back as tokens. So it's a partial JSON coming back, not a full JSON object that you then have to stitch together the full message to show in the UI. But it'll allow you to do what it looks like a typewriter going across the screen versus it wait for the whole thing to come and then go out. Because I think that app that we were just looking at is so slow because it's not doing streaming. It's just waiting for it. It's got them all buffered, and then it comes out. So you can do streaming to help with the user experience. You have 2 knobs. Temperature is like the creativity of the response. How creative do you want it to be? And the top P. Yeah, with RAG applications, I've seen them perform best between 0 and 0.3. If you go over 0.3, then they can sometimes hallucinate easier because you want it to be creative, so it makes stuff up. Top P is another knob that you have. That's going to be going off of the next probable list of words or tokens. I've heard you should only tweak either the temperature or the top P. You can tweak both, but for your own sanity, only tweak one at a time to see what you got. Because it's like anything, when you're debugging some code and you want to try something, you delete what you've got and then you start out again. Well, you want to only do a little at a time. Don't erase 3 weeks of work just because you want to try something out. So for your sanity, just do one at a time. Tools, that's the function calling that a lot of the LLMs do now. But very useful, especially in real world scenarios. Okay, so some of the functionality that we saw in the demos, the loading and saving of history. So that Cosmos app does keep the history of the sessions in the Cosmos DB. If you're writing one in the real world, you might be a useful thing. The feedback, the thumbs up, thumbs down, that may be very useful to understand whether or not your application's going off the rails, or if it's great. But most likely you're going to see thumbs down. You're not going to see a lot of thumbs up. Token usage, you'll want to make sure token usage isn't terrible. But so you'll want to monitor that. Pre-processing and post-processing. You may or may not want to trim some stuff off before you return it to the user. And you might also want to do some sentiment analysis on what the user's asking. Are they really perturbed and they do want to actually talk to a human right now? Or do you really want to pass that off to the LM and keep the conversation going? You might want to do some step in between the pre-processing before you go to the LLM and to continue that, or the post coming back. Let's see, so some more application concerns. So thinking about getting this thing into production. You're going to want to make sure you've thought through the whole data privacy thing. And that also has to do with authorization. I don't know about you guys, but trying to add authorization onto a system after it's already written is not the best in the world. You might want to design that in to begin with, so that if I log in as Jason Haley, I can only see what Jason Haley should be authorized to see. That sort of thing. You don't see that in too many demos either. Latency is something you want to take into account because this is an API call, and like I said, you have a retrieval application first, and then you have the call to LLM. So you're going to need to kind of weigh latency there. There is such thing as called LLM ops. It's a subset of ML ops, which means thinking about after you get this thing shipped, what do you need to be monitoring, all of that good stuff. Don't throw it over the wall. And then everyone, I'm assuming, is familiar with unit testing. How about functional testing? You guys do functional tests, integration tests? So that's stuff that we know as developers. For the ML and AI side, they have these things called evaluations, because your evaluating system, it's like the whole breaking point. You train the model, then you use the model for inference. So you train it to do what you want it to do, then you get to use it. So with that sort of disconnect, the evaluation means that you're evaluating the model on how it did, versus when you write code, you're testing the code exactly how it executes. There's a disconnect there. You're testing your application and seeing how it responds. Did it respond the way you wanted it to respond? Does that make sense? That didn't.
You used a word earlier called deterministic, which whenever I talk about this is always a word I use to test, like unit tests are deterministic, right? Like 2 + 2 is always 4.
Yeah.
When I ask an LLM something, it gives me something that fits these criteria. But so my question is, how do you write that and get these evaluations in a consistent way, right? Like it's going to be slightly different with each question or each run.
Yep.
But how do you have like a rubric that's consistent? The rubric should be consistent.
Yeah. So so I've kind of described what a lot of the people are utilizing prompts for to have an LLM ground, because what you do is you run your system and you give it. So say it's an HR system. Is scuba diving covered in my benefits? I want to take scuba diving lessons. Are they covered? So you ask it. It does the retrieval step, comes back with context. So you got what's going to the LLM, and then you get what comes back from the LLM. So that's your data. That's what you use to do the evaluation. So it's that disconnect. So you gather the information in one step, and then you got to do a measurement. It's like, is this grounded? Is the answer the LLM come back with related to the context that I gave it? Is it similar? Is it fluent English? Is it coherent English? Those sorts of things. So what they do is they take the results, because you run it to gather the data, and then you evaluate those results. That evaluation is typically done with a one-step better model. So like a 3.5 GPT, but then use 4.0 or 4 to do the evaluation, to tell it, like, is it using the context? Is it useful? That sort of thing. So the majority of what and then how the one thing that I've seen a lot of people disappointed with is have it give you a score of 1 to 5 as to whether or not it's grounded. How close was it to what I gave it in context? I've heard that's not always that great. It's like I don't have a great comparison, but 1s and 5s and 4s, you're probably not going to see very many 2s and 3s. So that grading scale is not all that awesome sometimes. So you might come up with another way to up with the measurement. That's typically how they do it, 1 to 5, and then they have an LLM graded. So that's evaluations. Like I said, I'll make this available to you. I've got some resources on my site. I've reviewed a lot of the, I shouldn't say a lot, like a half dozen or so RAG demos out there. And which means I link to where the source is. I give the technologies used, the different RAG techniques that they use. Like, do they save stuff? Do they use semantic kernel? Do they use LangChain? What language do they use? That sort of stuff. And then kind of give you my review of it. But the RAG reviews might be interesting for you. A semantic kernel is something you probably start using if you're writing these in C#. It's an orchestrator that allows you to take a lot of the individual pieces out of the puzzle, so you can just kind of chat with an interface versus, having to use an OpenAI client and keys and all this stuff, and then memory. They take a lot of that stuff away. They're in the Python world, there are even more options, but in the C# world, it's pretty much semantic kernel. Then I've started this study notes series that I've done text to SQL. That's where you tell it you want to do something, and it comes back with SQL text and then runs it on the database to give you the result. There's a corresponding one that is on my short list to do, which is text to cipher, which is for Neo4j. So we're querying Neo4j graph database with text. And then I've got one on how to do graph RAG with C#. Then these are the demos that I showed, and there was an AI chat app hack in January that has a lot of videos, all geared towards the different things that I've spoken about here, but they're like hour-long videos on YouTube that offer that link. And then this is a link to this slide deck, and the bit.ly is as well. And I can send all of this stuff to Jason too if anybody needs it, or just feel free to reach out to me. But any questions before we end here? All right. Well, thank you all for coming in.
I have a quick question. So I've been doing some things with Copilot Studio, which is like a low-code development environment for chat apps, and as well as you can build your own ChatGPT, which you probably have access to with your account. There's like a knowledge section in both of those. What I'm assuming that's doing is basically this. Is that correct?
Yeah.
You add a database link, or you add something. It's implemented some kind of RAG pattern. Without any of and no controls on it. It's just here's my PDFs.
Right.
Do this with it.
Right, and I don't know of anything, so I can't keep this as me known as NDA because I don't know anything specifically. But I do not see why Microsoft won't solve this for people that use Office 365. I don't see why they wouldn't provide that capability for you to say these documents in this SharePoint or in this OneDrive are what I want to be accessible via my Copilot.
The Copilot product, if you get it from Microsoft 365, includes like searching the graph, the Microsoft graph. So it brings in all your SharePoint stuff and all that stuff. Yeah. I was thinking more like specific in like the Copilot the ChatGPT builder where you create one and add specific data. What if you have too much? What if your corpus is too big? And you can't use this model even with the big token windows. Like for instance, let's say I want to take all the Dungeons and Dragons books for first edition and kind of train a model to speak intelligently about those. But I don't necessarily want to train a model. What can I do besides, like, is there a deeper step after RAG?
Well, the next step that I've been looking into after I call this typical RAG or semantic RAG, where it's really just a semantic search and then a user's question off to, sometimes it's a semantic search with a little metadata. This is the user, today's date is this, so rank the more recent stuff for me, that sort of thing. So that I call typical RAG. The next stuff I've looked into is like graph RAG. And I'm not looking into it just specifically for graph database, but what I'm looking into it for is structured data that is relevant to the other data. So, like for instance, I don't know how to solve the problem of the too much data. Like for instance, the solution or the scenario I was looking at is I originally was looking at this article. It's called like the 18 mistakes to kill startups, but there's no summary in that article of the 18 mistakes. You have to consume the whole article to be able to pick out the 18 articles or the 18 mistakes. That is a problem you can solve with GraphRag because there's 18. If there are 1,800, well then will the 1,800 pieces of metadata fit into the context window? Well, if it won't, I don't know how to solve that. So it's like you need the system to practically solve the system or the problem in the retrieval step before you have the LLM reason enough to give you a nice answer back. So it's like a retrieval problem because you don't want to send all of those books across the wire. Even if the LLM was good enough to do that, you don't want to send that back, ask it one question, send it, retrieve it. You know? Yeah, so yeah, it's kind of like systems that get too large, you have to architect new ways to do it. And I guess I'm kind of at the point where I don't have enough practical experience with it to tackle that yet. But yeah, it's another problem that people are going to hit.
Have you played with Gemini or Llama 2 or anything like that?
Llama 2 a little bit, but not Gemini. And I played with Mistral. Yeah, that one's pretty good. I mean, the thing is there's like a half a dozen now that are all comparable. And I do think, I mean, I don't really mention function calling in this presentation. I do believe function calling or tools, sometimes called, is really going to be important for the LLM to be useful in an application. Because what that allows you to do is solve problems like how many customers are there. You expose a function that says, we'll answer questions about totals and summations, and then the LLM says, oh, I don't know the answer to that question. Let me call this function. And then it'll pass the parameters to it, and your logic can then figure it out. So I think that level of picking things apart is going to be really important to get to that agent level where you need features to be able to do, not just a conversation back and forth.
That through your text SQL or text graph query comes in handy, right? Because then that just becomes a tool that it uses for itself.
Yeah.
To go get that.
Yeah, I mean, it's a cycle. Because then you can look at that and say, okay, well, now I need to fine tune a model so they can do better graph, and I don't have to send all this stuff. Like that would be one solution to that large problem, is to fine tune it so you don't have to send so much.
What's that mean?
Fine tuning. So you don't want to fine tune a model to add knowledge to it. You want to fine tune a model you want to give it behavior. So it's like if you find that you're constantly sending a larger boilerplate prompt back and forth, then fine-tuning may be a benefit for you because you can pretty much fine-tune that extra stuff that you're sending in that prompt over and over and over into the system so you don't have to send it over and over and over. So like, for instance, like with the GraphRag stuff, I'm sending a lot of triplets of the entity relationships across the wire. There's got to be more compact ways to send that, and you could fine tune the compactness into it so that you can do a small subset, but provide a lot more information to it. So adding additional behavior on top of the model is what I hear. I haven't done it yet, but I've heard don't try to fine tune knowledge into the system because you might likely end up causing it to forget some of the stuff it already knows. Yeah, I'm not experienced in fine-tuning stuff like that. Behavior.
So one way people solve this by using SQL, by trying to do a SQL and then trying to do. But that creates another problem, which is now you dynamically generated SQL, so security.
Yeah.
That becomes all kinds of additional problems starts to pop up.
Yeah.
But it's a balance. Which one do you want to?
Yeah, there's a RAG demo out there that's on my short list to review that uses Postgres for storing, the structured data as well as vectors related to that data. the demo that I want to review, it kind of takes a half step. It uses function calling, but it only returns a filter. So it still controls the bulk of what it's going to do for the query. It just grabbing a query. It's just grabbing a filter. So you might not want to just run any SQL that comes back, but yeah, control it a little bit with filter. All right, but anyone has any questions or just wants to talk about this stuff, reach out to me. It's fun stuff. It is a rabbit hole. Once you start going down it, it's like you just can't seem to get enough of it.
Jason, which kind of applications in production have you worked on any of this?
Right now, I have 2 POCs where we haven't gotten anything into production yet, and one of them is Anyways, I'll say that for later. Reach out to me and I can describe the 2 POCs, but it's super interesting stuff.